Hey guys, so I'm going to talk about ENS v2 today and talk about how ENS v2 is designed and been somehow implemented and how does the migration step work from ENS v1 to ENS v2. So here's a brief introduction about myself. I'm just an extraordinary dev and somehow do open source software contribution in Ethereum ecosystem. And now I'm focusing on ZK, privacy, and protocol design kind of stuff. And I used to do core smart contract at Harvest Finance, and I co-host eTaipei, ZK Taipei, and I love to do privacy-related residency. And since I'm doing the talk in English today, I have written an article about ENS v2 a couple months ago in Mandarin. So if you guys are interested, feel free to look into that article as well. And I also created a group chat so that if any of you have other questions after this talk, feel free to ask in it, and I will share as much information I have to every one of you. A disclosure is that I'm only doing this as my interest and hobby in ENS, and I'm not affiliated with ENS. So this is purely my study and my understanding of ENS v2. So today, I'm going to. So before we start, I want to ask how many of you have heard of ENS before? Can you raise a hand? Okay, like a third. And how many of you own an ENS? Okay, yeah, roughly. So I'm going to slightly talk about what is ENS and how does ENS v1 work, and what are the ENS v1 limitations that bring into the change of ENS v2, and what are the challenges of migration and name resolution during the implementation of the ENS v2, and kind of deep dive into the some of the implementation of the ENS v2, and also bring out some tips if you're new to ENS and what can you do within the ENS ecosystem. Okay, so let's talk about what is ENS actually. So ENS is the domain name system for Ethereum. So if we are going to access a website in a traditional internet world, we'll have to look up a specific domain name into a DNS server and to get the IP address of the website, so that we can know where do we have the IP address to access the website. So this is kind of the idea of a domain name system, to abstract things and make things easier into human readable text that will be easier for the user to access. And so in a Ethereum kind of blockchain world, what can it brings to the user? So I'll use a money transfer example. So if we want to transfer money to our friends, we'll often have to ask, what is your bank account and where can I send the money to you? So it often bring out sending a long text about which bank it is, what is the bank account number, sort of things. And that's also the case in Ethereum ecosystem. But with ENS, things changed. When you're sending money to your friends can simply set that, what is my username? Like, I'm vitalik.eth. And the only thing that you'll need to do is to look up this username into the ENS protocol, and the ENS protocol will do name resolution back to you saying that what address tied to this ENS name. And so you'll know, or your application or your wallet will know, where do they send the money to. So that kind of abstract all the user experience and make everything easier for the user. So the reason why ENS matters in Ethereum ecosystem is it brings a human readable text to all kinds of application or protocols to replace addresses with memorable names, and also it's extensible. I'll bring out this in the following pages, but it not only can store what this username represent as an address, it can also represent other things like content hash and text. And also because of this extensible feature, it can also be a new Web3 identity for a user in the blockchain world that you can store all sort of things or all sort of records that you want to bring with you into different applications. And it also aligns with the blockchain core value, which is decentralization, permissionless, and credit neutral. So here's the common use case, and it's also why it not only represents addresses, it also represents content hash, and it also represents text. So you can see the red boxes that I highlighted. So it can simply represent wallet address. So you'll know that what this username tied to which address on the blockchain. And also it do multi-chain support. If you're not familiar, I'll talk more about what multi-chain and what layer 2, layer 1 represent in this ecosystem. But it do support multi-chain, which is you can use this username across all the chain in the Ethereum ecosystem. And also it represents IPFS content, which is a decentralized web content storage service. So you can simply store a IPFS hash to your ENS username, and that can be resolved into a decentralized web service, like using eth.limo or something. And also it can tie to traditional service, like GitHub or like Twitter account. So you can store all sort of things to this decentralized identity representation. So which brings it to so much potential beyond just resolving a username to a address. Okay, so that's kind of what ENS can do and what it represents. And I'm now going to slightly talk about how ENS v1 will actually work. So there are two core components inside ENS v1. The first one is the registry. The registry is, you can simply understand it as a table that store, this name, who's the owner of this name, and what is the resolver of this name. And the resolver I'll talk about in the next slide. But the resolver will be stored also inside the registry. So if you're trying to resolve a username, you first interact with registry to get the resolver tied to that ENS username. So if I'm trying to figure out what Vitalik.eth linked to which address, I'll first get the resolver, which is 0x123a in this case. And once I have the resolver address, I'll then interact with the resolver. So the resolver is an independent contract that stole all the record that we just mentioned, like addresses, content hash, and text that tie to a user. So once we have the resolver, we'll interact with the resolver to get all the records that tie to that user. So here are the complete flow of how user interact with registry and resolver. So first, you get the resolver that tied to that username. And once you have that address, you interact with the resolver itself to get the specific record that you want to access, like address, text, and content hash. And so that's how the resolution work. And I'm going to slightly talk about registration flow because this is a core limitations that ENS v2 is trying to solve. So in a blockchain world, there is a case that transaction will get front run, which just mean that you're sending a transaction, but if someone managed to find a way to send transaction faster than you, your transaction will not be executed, and you'll be your transaction will fail, and the transaction happened before you will successfully executed, and that will be the success case. So in order to protect the user, we want the people that trying to register the username can successfully register the username. So we have to design a mechanism to overcome this limitation. So this is a commit and reveal kind of scheme that is commonly used inside the blockchain world. Do you have a question? Oh, no, nothing. And so this is commit and reveal. So commit and reveal require two transactions for a user to register a username. So first, you commit a a list of information that you want to register your username in the later transaction. So in this case, you register the duration of the username and the owner of the username and the label, which is actually, take Vitalik.eth for example, it will be Vitalik itself. And the duration will be how long do you want to own this username. So first you commit this hash into the contract, and then after a minute, you will send another transaction to co-register, and which you reveal all the information that you committed hashed in a previous transaction. And if those information matched, we can identify that a minute ago you were the one that sent the commitment, and we'll know that, oh yeah, you have commit before, and we'll give this username to you. And then in the last step, we'll transfer or mint the ENS name, which is implemented in ERC 721, but you can just think it as a name card to the user itself. So we'll need this kind of mechanism to prevent front run in ENS v1. So that's just give everyone a brief idea about how ENS v1 overcome this. So here's a couple feature that ENS v1 has. It's mainnet center, like everything is on mainnet, and one singleton registry, which just mean that every username, all the record, you can access through a single registry contract, like the lookup table that we mentioned in a couple slides before. So take .eth, for example. .eth have a registry contract where we can get all our information that we need. And also it's ERC 721 based. So all ENS name is a ERC 721 token. So that's some of the feature that ENS v1 has. But also, these brings to the limitation of ENS v1. So since it's mainnet centered, it requires high gas fee in a compact, condensed network situation that user have to pay a high gas fee to register their ENS name, to set record, to do all kinds of transaction and all kinds of action for the user. And also because it's one singleton registry, so it will be a bit hard for what we call subname management. I'll talk about subname in the next slide, but you can imagine subname as a name that's underneath your ENS name. Like if you're Vitalik.eth, you can imagine it like different path under a domain name. So take Vitalik.eth, for example, you can be app.vitalik.eth or doc.vitalik.eth. So each different subname belongs to Vitalik.eth is also being stored inside the same registry contract. So what we can imagine is that if Vitalik.eth, this username, is expired and this name is been transferred to other user, all the previous store record like doc.vitalik.eth, app.vitalik.eth will still remain in the same state on chain. So everything record, every sort of things that we stored before will remain unchanged. So the new user will have to replace all the previous record himself. So it'll be a bit complicated. And also it's all implemented in ERC 721. So it's if you know ERC 1155, it's also a bit not that extensible comparing to ERC 1155. Yeah. So in the previous slide, we talked about subname. So this is kind of how subname is work. So in a most simple use case, subname is also a record, just like text, content hash, and address that tie to a ENS name. So like sub2, sub1, sub3 name.eth. It's just a record that type to the name.eth. So no token or no feature, no utilities tied to that subname. So in order to give utility or to give the ownership of that subname, we ENS Lab created something we call name wrapper. So name wrapper is a wrapper around the original ENS name. So the idea is to transfer the original ENS name into a ERC 1155 contract. And that contract will be the new owner of the original ENS name, and all the subname will be issued as a ERC 1155 token after that. And they created something called fuses, which is a permission system, one-way permission system. This is why it called fuses. So once you burn it or once you initiate it, there's no way going back. So they created this one-way permission system for the name wrapper in order to give more utilities to the subname holders. So it can give them permission to transfer the token, to set their own resolver, and to do their own subnames, like the fourth layer of the subnames tied to that ERC 1155 token. So it's a bit complicated to do subnames in the ENSV1. So adding up with all these difficulties that they encounter in the ENSV1, they propose the ENSV2. So the main issue that they want to solve, the first one is the subname limitation that we just talked about, and also the high gas fee that that's being caused by staying on layer 1. And their solution will be this: the ENSV2, which is a whole system architecture that re-implemented a lot of the core ENS contract, and also they do their own layer 2, their rollup, called name chain, to resolve the high gas fee. So this is how ENSV1 work. It's a flat registry, one registry, and store all the different .eth name to it. And in ENSV2, they turn this flat registry into a hierarchical registry, which makes it customizable. Each owner of their ENS name, they have their own registry, so they can decide their own issuance rules, their ownership rules, and once the name is being transferred, they can just place it with another new empty registry, so all the previous record will be washed away. So it's a lot easier for a new owner to manage the name. And then we talk about the name chain. So a couple question I have about once they announce name chain is, why do they want their own rollup? And what kind of rollup do they want? And how do they build their own rollup? So why do they need their own rollup? Is because back in the day, when ENSV1 is implemented, there's no such thing as rollup, or it's not been well explored yet, so no one know what is really the scalable solution in the future. So L2 centric isn't a thing during that time. So, but now with L2 is entering a L2 centric era, they want to be L2 agnostic, which means that they don't want to stand with a specific layer 2. They want their own layer 2 so that they can work with everyone. They don't want to be friendly with a specific layer 2 like they are only supporting them. And also with their own name chain, their own rollup, they can reduce the gas fee, and they can also provide gas subsidies to the user to compensate them with registering name. And also in V1, they use ETH as the name pricing. And now with their own name chain, they can do USD pricing, and also they can do instant registration. Unlike in ENSV1, you have to do commit and reveal. Now with their own chain, they can do instant registration, because in their own chain, they can decide what the block time, and with the new tech, the block time can be reduced significantly. And about what kind of rollup, they have been discussing for a while about whether to use the OP rollup or to use the ZK rollup. And at the end, they decide to go with ZK because of the faster layer 1 finality. And this is super important. I'll talk about in the later implementation why instant or fast finality is important in a name resolution case. And then how do they build their own rollup? As we know, building rollup is a super complex thing. So they are deciding among which rollup as a service they want to go to. So they have discussed about OP-Stack or using Arbitrum Nitro and all kinds of ZK VMs that are popular today. And at the end, they go with the Linea using the ZK VM, as they have a close relationship of working together on the subname. And also in the Linea ZK EVM, it's a type 2 ZK rollup, and it takes only 2 epoch time to reach the L1 finality. And so once they decide all the things they want to do, the next step will be what are the biggest challenges they encounter. So the first thing is, how does the migration work? How do they migrate the user from ENS v1? And how does the backward compatibility work? How do they also support the previous user? Even the previous user don't migrate to v2, they can also support and resolve their v1 name. So this is kind of the core important part about how ENS v2 is using. And I talk about 2 actions today. The first one is migrate. How migrate work? How do they move their chain between move their name between layer 1 and layer 2? And how does the name resolution work? And for first part, I'm going to talk about how migration work. So this is the migration flow. So the key point is that it's a layer 1 plus layer 2 solution. So no one is being left behind. You can keep your name in either chain, and you can decide by the user itself. So first of all, the user sent their username, their ERC721 or 1155 to the migration controller contract. And as we talk about the name wrapper, if it's a ERC 1155, which is mean it's a subname, it will unwrap the subname first. If it's a top-level domain name, then it won't go through the unwrap. And the user can then have 2 steps to decide whether they want to migrate their name to stay on layer 1 or they want to migrate their name to layer 2. So if the user decides to stay on layer 1, it will just call the ejection controller, and the ejection controller will just call the registry v2 to register the name. So it's pretty simple. And if we want to migrate to layer 2, it will send a message to their name chain bridge, and the name chain bridge will send a message to the bridge controller on layer 2 and transfer the ERC 1155 new ENS v2 name to the user. And why we say it's transfer is because before the name chain is being deployed, all the record in ENS v1 will be snapshot and sync to ENS v2. So all the name will be minted to the bridge controller while on name chain. So it will just been minted already, and so it will just be purely transferred to the user in this case. So this is why ZK is important. This is why instant finality is important, because the name will either be held on ejection controller, be held on migration controller because the user transport the name to here, or it will be held on bridge controller. So there will be a time where the owner is not actually the owner of the ENS token, because the token will be held inside either the bridge controller or the migration controller. So ENS will want to have faster finality so that their resolution can work successfully to know whether the name is on layer 2 or whether the name is on layer 1. So once we tackle the first difficulty, which is the migration, then we focus on the backward compatibility. So this is how, with the ENS v2 and v1, the backward compatibility resolver actually work. So the user calls a contract called universal resolver v2. You can just understand it as a single entry to resolve all the name, and it will call the root registry to get the take for example the .eth name belongs to which registry, and it will returns it to the address of .eth registry. And once we figure out which registry this name belongs, the user can interact with it with the specific registry and to get the resolver, like in the ENS v1 resolving process, to get where do I actually interact with the resolver to get the exact record that I want. So in this case, in layer 1, there will be a ETH fallback resolver. So in my understanding, in the ENS v2 registry, all name, unlike in v1 has their specific resolver, they will all point to ETH fallback resolver. And so no matter what name you own, once ENS v2 has been deployed, your name will be linked to ETH fallback resolver. So all resolution goes through ETH fallback resolver. And in the ETH fallback resolver, there's two paths to decide how to resolve the name. If you haven't migrated, it'll just point you to the original universal resolver v1, which resolved the v1 name. And if your name has been migrated to v2, it will call the name chain to do CCIP, what we call wildcard resolution. And it's a bit complex, but you can just imagine it as there's two ways, one v1 and one v2, and it can work either way. So no matter you migrate your name or not, whether you migrate your name to layer 1 or layer 2, all three options can be successfully resolved with the ETH fallback resolver. So does this impact their partners? It will be pretty simple for the partners to upgrade to ENS v2 because for the partner, they either interact with ENSJS package to get the name resolved, or they interact with the universal resolver to resolve the name. So in either case, ENS Labs can simply just upgrade the address that pointed for resolving to universal resolver v2. And if you're a protocol that you resolve directly with a contract, you can just upgrade the contract address to universal resolver v2 as well. And if you're an app developer, you can just upgrade to the latest ENSJS package so that you know where resolver, the address of the universal resolver v2 is. So it'll be pretty simple to upgrade to ENS v2 for all kinds of partners. So with solving the ENS v2 and the name chain, the whole protocol can have zero downtime for name resolution, and for the user, they can have opt-in control to decide how they want to migrate their name. And with the name chain, user can have gas subsidies and also have backward compatible name resolution. So with the whole system architecture like this, we're going to slightly talk about how the core contract actually work. So this is the migration and ejection controller. So to simply understand it, you can just understand it as there's two steps. In this part, you can decide, the user can decide they want to keep their name on layer 1. So you just interact with the layer 1 ejection controller to migrate their name to layer 1. And if you want to move your name to layer 2, it will just send a message to the bridge to move your name to layer 2. And if we want to use the ETH fallback resolver, first it just verify your name and suffix. It's a I can just simply talk a bit about this. This might be too complex for most of the user, but first it just verify the name and suffix to see that the name is actually the one that you're trying to resolve. And if your name is just purely .eth, it'll just call the ETH resolver. And if your name is still on v1, it'll just call the universal resolver v1. And if your name is on v2, it will form a complex request call from CCIP and interact with the name. CCIP is a big topic, so if anyone is interested in this, I can provide more links in the future. But you can imagine it as a off-chain name resolution, but being able to verify on-chain. Okay, so lastly, I'm going to talk a bit about some ideas that if you're a newcomers to the ENS ecosystem, what you can do. So first, you can register your own ENS name, and here's the ENS app, and you can just register your .eth name here. And if you want to get your subname, you can use Coinbase and Uniswap. They provide free subnames to their user. And they also work with GoDaddy, so it doesn't work only one way for .eth to address. You can also use traditional DNS name to link to your on-chain address. And you can also bring your DNS into ENS, bring your traditional website on-chain into an ENS name with a complex tag, which is for another day. But if you have a DNS name like coscup.org, you can also bring this as a ENS on-chain and to bring subnames to your user. Okay, that'll be all for today. And here are some resource and reference for anyone is interested to dive in more. And these are the links that I shared in the previous slide. So if anyone has any questions or things want to talk about more, I can share more detail in there. But yeah, that will be pretty much for today. To see if anyone has any questions.
Thanks to Ryan, and so nice talk. And maybe we have one question for. Does anyone have questions? No? Okay, I might do some research about how to migrate my ENS handle to the V2 tonight. Okay, so thanks to Ryan, and give